Another interesting problem, 134. Here we have this sector, and there is a slot on this sector. And we have this rotating arm, which is rotating with angular velocity of omega OC, omega of this bar. And there is a pin. The pin is on this bar, is on OC. And also from the other side, the pin is on this slot. So whenever we rotate this arm, it's gonna move this pin, and because of that, the sector is gonna start to rotate too, right? And the question here is, what is the angular velocity of this sector? If I call it omega, what is the angular velocity of it? And also, what is the relative velocity of this point with respect to the sector? I mean, which means the velocity of this pin on this slot. So try your best to solve this problem. After 10 minutes, see the rest of the video. So to solve this problem, I'm gonna use this rotating coordinate, XY coordinate, which is attached to this body, to this sector. So this XY coordinate is rotating with this. Why I am doing that, you're gonna see we can find omega in those relative velocity equations. How it works, look at this. Look at point A, which is relating the movement of this rotating arm to rotation of the sector, right? So A is our critical point, which we are going to use it. Do we know the actual velocity of A? Yes, we do. How? A is on this arm, and this arm is rotating, right? So the velocity of A simply is going to be r times omega in this direction. Velocity of A is going to be OA times omega of this. So OA times omega of that bar, which is OC. And the direction of it is going to be perpendicular to this bar. So we know the actual velocity of A. From the other side, if you try to find the velocity of A using this rotating coordinate, let's write the equations together. Equation for the relative movement for rotating frame. Velocity of A is going to be equal to velocity of the origin of the coordinate B plus relative velocity of this pin in this rotating coordinate plus omega of the coordinate, which means omega of this sector, cross R, which is BA here, right? This is the equation we use for rotating frames. Now look at this equation and see how many knowns and how many unknowns do we have here. Velocity of A, we know it. We know the direction of it, we know the magnitude of it, so everything is known in the left side of this equation. Velocity of B is 0. Velocity of A in that coordinate, V rel, is it known? No, we don't know the magnitude of it. But do we know the direction of it? Yes, we do. If you sit on this sector and look at A, you're going to see A is moving just in the X direction, right? So V rel, the magnitude is unknown, but the direction of it is going to be just in the I direction. So we have only one unknown here. Omega of the frame, XY frame, or the sector, they are the same. Do we know it? No, we don't. But do we know the direction of it? Yes, it's going to be in the K direction. So we have only one unknown here. Times BA. Do we know this vector? Yes, of course. It's going to be 0.4 meter in the I direction. So in this vector equation, we have two unknowns, V rel and omega, and two equations because it's a vector equation. If you separate I, J terms, you're going to have two equations, right? So let's just write everything down. This angle is 30, so this angle is going to be 30, right? Velocity of A is going to be 2 times OA, and OA is given. OA is 500 millimeter, is given. So this is going to be 2 times 0.5 meter, or it's going to be equal to 1 meter per second. So velocity of A in the vector form is going to be 1 times sine of 30 in the I direction, and 1 times cosine of 30 in the J direction. So velocity of A is going to be 1 times sine of 30 in the I direction plus cosine of 30 in the J direction is equal to V rail. We don't know the value of it, but we know the direction is going to be in the I direction, right? And omega, as we said, we don't know the magnitude of it, but the direction is always in the K direction. It can be positive or negative because we have planar motion. In 3D motion, omega is not always in the K direction. Cross product to BA, and BA is 0.4 in the I direction. We have only one cross product here. K cross I is J, so this is going to be 0.4 times omega in the J direction. So it's simple equation, right? If I separate I and J terms, in the I direction we have sine of 30. Here we have V rail only. So V rail is going to simply be 0.5. And in the J direction, cosine of 30, we have it in the left side of the equation. In the right side of the equation is 0.4 times omega. So we can find omega from the second equation, right? So V rail is going to be 0.5 meter per second. Because it turned out to be positive, it means it's going to be positive in the A direction. It's to the right. And omega is going to be cosine of 30 divided by 0.4. So it's going to be 2.17 radian per second. It turned out to be positive, so it means it is in the K direction. It is counterclockwise.